All right, we're in business. Welcome to Pre-Calculus with the Seal Meister. You ready? I'm ready. So we got to talk about logarithms. Emphasis on the rhythm, because when we get going on logarithms, like you are in a groove, a rhythm, no doubt about it. So the part that you'll remember is there's all these rules, and I think, if I'm not mistaken, can I go full screen here? Come on. It's not allowing full screen today. Enter full screen, please. There we go. That's what I wanted. Um, Logarithmic function with base b. So there's this funny way we write these. We go like y equals. If I get my pen working too. Sorry, I'm so rusty on getting my recording together. Y equals log b, base b of x. So that's a logarithmic function. There's this little base b. I know it sounds bizarre, but what it actually is, and I can turn it around too, this might help you, or I could write log base b, log base b of x equals y, which is actually kind of my favorite way to write it, just for now. Because here's the idea. It is equivalent to saying b to the y equals x. So here's the deal. We have two different functions here. We've got this log function and its inverse exponential function. They are inverses of each other. They actually, for x and y, if you pick an x and put it into either one of these, you're going to get the same y that matches in the output. So they're inverses of each other in a lot of ways, but they're the same relationship. You're just inverting them as you go along. So you can express them both ways. One of them is called the exponential expression of the relationship between x and y. So this is exponential form. And the next one next to it is a log base b of x equals y. That's the logarithmic form. Oh, that's what's said on this. Oh, man, I had all that room over to the side. You know, that would go over there. That's what I get for zooming in. I didn't see the rest of the notes. But yeah, that's exponential form. You convert back and forth. My favorite way to look at it, and I'll just do that in the extra space that I have. I really like doing this. This is my fave. So I go log base b of x equals y. I think of it this way. I think of taking this power, or this base, to that power is equal to that number. It's cyclical. I actually visualize that in my mind. So it's like I'm doing an exponent, so I use the caret symbol, b to the y, and then up here I'm saying it's equal to, if I can get this right, x. So the expression, converting it from log form to exponential form, I go over there and I write b to the y power is equal to x. So I just do b to the y power is then equal to x. And that's the flow chart that happens in my brain. That's how I convert them. You may have a different way, but that's how it flows in my mind. You can tell me another way if you've got one. I'm up to, if you got some fancy way you think about it. So base b to the y is equal to x. And there's your converted form. So again, they're just different ways to express the relationship between x and y. They actually are equivalent expressions. So they graphically, though, when we get going, they are inverted. The relationship between x and y stays kind of similar, but it's pretty nifty. Let's talk about the three things we do with the algorithms. We evaluate them, we simplify them, or expand them. Those are kind of in the same vein. We simplify or expand them, and we graph them. That's a lot of the main things that we do with them. So you got to look at the instruction and be careful what's being asked of. So in this case, when I say evaluating logarithms in this case, the first thing that I do for evaluating logarithms is I set it equal to x. Because basically I'm trying to find out what's it equal to. So I'll throw x in there as my unknown. I don't know what log base 2 of 8 is. But if I put x in there, I'm going to find x, because I'm good at finding x. Y'all are good at finding x. I'm going to use what I just learned. That means now from this, then you want to convert. So I call this kind of my part one, is that set it equal to x. Big help there. Now, the next part is convert to exponential. So watch this. 2 to the x. Now that's equal to, remember, Got this flow chart going in my brain. 2 to the x is equal to 8. So I got the conversion going on. Now you're looking at it, and if you know your exponents a little bit, you're going, oh, 2 to some power equals 8. I know that one. 3. 2 to the third is 8. So the x equals 3. So these are meant to be relatively easy. And then from there, I can finish this off. So basically, dot, 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 x equals 3. No big deal. Okay, that's one way to look at it. We can do it for another one. Put x over here. 3 to the x equals that thing. So I'm going to go 3 to the x equals rad 3, which we know is also to the 1/2 power. That'd be handy. So if I wrote this as 3 to the x equals 3 to the 1/2, well, I'll be. If I got 3 to something equals 3 to the 1/2, that something's got to be a half. Nice. Just giving you a way to rewrite it in exponential form. Solve for that x, you're good to go. Let's do a couple others, see what you can come up with. 5 up to the x power equals 1/25. And it starts to get kind of fun. So you go 5 to the x equals 1/25. Then you have to know something about exponents. So you can't get through logs without knowing your exponent rules. You just can't. Like that 25th, you're going to start wanting to rewrite those. You're going to go, ooh, yeah, that's 1 over 5 squared. Oh yeah, forgot about that. Should probably make a better squared in there. I can do that. Squared. And if I have squared in the bottom, I can also flip it over. So that's 5x to the x equals 5 to the negative 2. Now I see x. Now I get it. Now I get it. X has to be negative 2. And I'm just looking because same bases, I can compare the exponents home free. So let's go up here and write x equals negative 2. Cool. So far, so good. So a couple others. There's some nuance to some of these. So we'll make some quick work of these and just get some examples out there for you. And then I imagine you're probably good to go. So I see now I got 4 to the x equals 1. And if you remember, this one is important because some base to x equaling 1 has one solution only. The only way you're going to get 1 out of a base, some power, is, do you know what that x has to be? 0. So keep your eye out for that one. That's a fun one. X has to be 0 in that case. So if you have a log, now you can actually generalize that one too. The log of 1 of any base, doesn't matter. Just natural log of 1, log of 1, anything log of 1, x equals 0. You're going to end up with that. It's going to be equal to 0. So if you want to do that, log base b, I don't care what kind of base you got, of 1 ends up being 0. That's a general rule. Now, rolling. Put some x's in there. Let's just chalk these up. Let's just do them because I want you guys to play with a bunch of examples later on your own. 7 to the x equals 7. Hey, x equals 1. Like that one. So that's another nice general rule. If base and the number you're taking the log of match, you're going to get x equals 1 because you're going to have 7 to what power is going to give you the same number, and that has to always be 1. So I'm going to put over here log, or whatever I can write, bog, log, base b of b is going to give you 1. That's a cool rule too. If you're taking the log of the same base of that base number, b to the first is going to give you b. B to the 0 is going to give you 1. Nice. And 8 to the x, no faking. That's Vanilla Ice I'm referring to. He's a home improvement superstar, in case you didn't know. Okay, 8 to the x equals 2. Ooh. Do you know what you get for that one? If you don't know, you know what you could do? You could mess with 8 and you could get it to be the same base. If you can get these guys to have the same base, it helps you solve it. I know that 8 is 2 to the third to the x equals 2. And I know that 2 to the third, now you already probably know what this is. Some of you are doing it mentally, great. No worries. 2 to the 3x equals 2. Kind of see how if you can convert exponential equations like this to having the same base, then you have a means to compare them. Now that they're both base 2, I can go, oh, well, this guy's got a power 1. Hey, I solve 3x equals 1. X equals 1/3. You might have known that the cube root of 8, 1/3 root, 1/3 power gives you 2. You may have seen that. But to compare those, you want to have the same base. All right, running to the next stuff. So properties of these. Dang it,